Hello students, welcome you all. This is the 10th video on the topic matrices. In today's class, we are going to study inverse of a square matrix. Inverse of a square matrix by elementary row or column operations. Let capital X, A and B be the matrices of the same order such that X can be written as the product of A into B, and we denote this equation as equation number 1. In order to apply the sequence of elementary row operations on the matrix equation 1, we will apply these row operations simultaneously on X and on the first matrix A of the product AB on the right hand side. Similarly, in order to apply the sequence of elementary column operations on the matrix equation 1, we will apply these column operations simultaneously on X and on the second matrix B of the product AB on the right hand side. To find the inverse of a given matrix using elementary operations, we write capital A is equal to I into A, and we denote this equation number as 2. Then we apply the sequence of row operations on the equation number 2 till we get the equation I is equal to B into A. Then the matrix B is called the inverse of A, and it is denoted by B is equal to A to the power minus 1. Similarly, to find the inverse of matrix A using elementary column operations, we write A is equal to A into I, and we denote this as an equation number 3. And let me apply the sequence of column operations on equation number 3 till we get I is equal to AB. Then matrix B is called the inverse of A, and it is denoted by, once again, B is equal to A to the power minus 1. By using these equation number 2 and 3, one can use the elementary row operations or elementary column operations to find the inverse of a matrix A. Dear students, by using these operations, we are going to solve few examples from the exercise 3.4. Let me read the question. Using the elementary transformations or operations, find the inverse of the following matrices if it exists. We have the few questions here. We will take one by one, and we supposed to find the inverse of a square matrix. Let me take the questions one by one over here, and there is one regular question in the examination for 3 marks in the part C section. Let me begin with the first question. Let matrix A is equal to, the first row elements are 1 minus 1, 2, 3. In order to use the elementary row operations, as I told you in the previous slide, we can write A is equal to I into A. And we have to apply the series of, or the sequence of, the row operations one by one till we get I is equal to BA. Then in this case, B is called the inverse of A. Now, let me use the row operations to the equation given above. Let me replace A by the given matrix 1 minus 1 2 3 is equal to the identity matrix 1 0 0 1 into A. Now our intention is to convert the left hand side matrix into the unit matrix I, and in this case the elements of this matrix should be 1 0 0 and 1. To get the unit matrix to the left hand side, we apply the sequence of the row operations. Dear students, you can keep it in mind. The second row first element we should get a 0. Looking at this number, we can apply the row operations. In the second row we need a 0, therefore let me change the second row. R2 changes to. We multiply these numbers to the respective rows. The second row element will get multiplied with the corresponding elements of the first row, and the first row element will get multiplied to the corresponding element of the second row. Therefore, here we write R2 changes to R2 minus, that is 1 times R2 minus 2 times R1. By using this row operation, we get the element 0 in the second row first element. Dear students, these are very easy examples but bit complex. You have to solve these examples with patience, then only you are supposed to get the accuracy for these problems. Now let me apply the first row operation. Now we are going to change only the second row, not the first row. Therefore, let me write the first row elements as it is, 1 minus 1. And let me perform the row operation. R2 changes to R2. Our first element of the R2 is 2. According to the row operation, minus 2 times the corresponding elements of the first row is 1. Therefore, here we get 2 minus 2 is equal to 0. Therefore, in the next matrix, we have the second row first element is 0. Similarly, to get the second element of the same row, we apply the same operation to the above matrix. R2, the second element is 3, minus 2 times the corresponding elements of that row is minus 1. Therefore, here we can write 3 minus of minus plus 2, which is equal to 5. Therefore, the second row second element is 5. Therefore, our left hand side becomes 1 minus 1 first row, second row elements are 0, 5. Similarly, we will apply the sequence of the row operation, same row operation to the right hand side. Then we get the first row to the right hand side remains the same, 1 0. And the second row can be written as R2 changes to R2 minus 2 times R1. Therefore, R2 element in the first row is 0, minus 2 times according to the row operation, minus 2 times the corresponding elements of the first row is 1. Therefore, 0 minus 2 is equal to minus 2. Therefore, here we get an element minus 2. Similarly, the second element of the same row, by applying the same operation, we get R2 is nothing but 1 minus 2 times the corresponding elements of the first row is 0. Therefore, we get 1 minus 0 is equal to 1. Therefore, the second row second element is 1 into matrix A as it is. Therefore, the right hand side is containing the elements 1 0 minus 2 1. Dear students, our next step is we should try the 0. Secondary diagonal elements must be 0. Therefore, here we should get a 0. That is in the first row. We have to change the first row. And that row we can change with the corresponding elements of the second row. Therefore, in this case, we cross multiply with the numbers of the respective row to the next row. The 5 second row element will get multiplied to the first row, and first row element will get multiplied to the second row. Since we want the 0 in the first row, therefore we write R1 changes to 5 will get multiplied to the R1. Therefore 5 times R1. Since both the elements are different in sign, always we have to go for addition. Therefore 5 times R1 and 1 times R2. Therefore we will get R1 changes to 5 times R1 plus R2. We get the matrix to the left hand side. Since we are changing the first row, second row remains the same, 0, 5 as it is. Now let me change the first row. 5 times R1, 5 times R1, 5 times R1 is 1, plus corresponding elements of the same row is 0. Therefore 5 ones are 5 plus 0 will get a 5. Therefore the first row elements in the matrix is 5. Similarly, we can apply the same operation to the second element of the first row. That is 5 times R1, R1 element is minus 1, plus the corresponding elements of the second row is again 5. Therefore minus 5 plus 5, that gives 0. Therefore element in this case is 0. This is equal to the same operation we can perform to the right hand side of the equation. Second row elements are as it is, minus 2, 1. Now let me apply the same operation to the right hand side. 5 times R1 first element is 1 plus R2 corresponding elements of that row is minus 2. Therefore 5 minus 2 is equal to 3. Therefore we have an element 3. The same operation we can perform to the next element. 5 times R1, that is 0, plus R2 corresponding element of that row is 1. Therefore 5 zeros are 0 is plus 1, that gives 1. Therefore the element in this row is 3 and 1 into matrix A as it is. My dear students, this problem is not yet over because our intention is to convert the left hand side matrix into the unit matrix. Therefore, if you look at this problem to the left hand side, we have the matrix containing the elements 5, 0, 0, 5. Here we want 1 in the first row first element and 1 in the last row second element. To get 1 in the first row, we will apply 1 by 5 times R1 to the first row, and to get 1 in the second row, we apply 1 by 5 times R2, these two operations separately to the first row and second row on both the sides. Now we'll get these operations in the next row. Now the left hand side 5, 0, 0, 5 becomes 1 by 5 into 5. This gives 1. 1 by 5 into 0, that gives 0. 1 by 5 into 0, it gives 0. And 1 by 5 into 5, this matrix is there in the previous slide. Therefore 1 by 5 into 5, that gives 1. Therefore our left hand side becomes now 1, 0, 0, 1, which is nothing but a matrix sign. The same operation we can perform to the right hand side. In the previous slide, we have the right hand side containing the elements 3, 1, minus 2, 5. And both the rows are multiplied by 1 by 5. Therefore, here we are getting the new elements 1 by 5 into 3 by 5. 1 by 5 into 1, that gives 1 by 5. Similarly, we are multiplying 1 by 5 to the second row. Therefore, 1 by 5 into minus 2 is minus 2 by 5. 1 by 5 into 1 is 1 by 5 into matrix A. Therefore, left hand side becomes now I is equal to, this matrix is denoted by the notation B into A it is. Therefore, B is nothing but A inverse, and the inverse of the matrix elements are 3 by 5, 1 by 5, minus 2 by 5 and 1 by 5. Therefore, the inverse of this matrix is nothing but 3 by 5, 1 by 5 in the first row, minus 2 by 5 and 1 by 5 in the second row. My dear students, these problems are a bit difficult to convince on the screen, but if you practice 1 or 2 times, it will be easy for you to understand. These problems are sure in the examination, and the weightage for these type of examples is 3 marks. You practice this example repeatedly so that you can get the results accurately. Dear students, let me start with one more example. Example number 3. Let matrix A is equal to, the first row elements are 1, 3, second row elements are 2, 7. We should find the inverse of this given matrix. As we know, in order to use the elementary row operations, always we write capital A is equal to I into A. Substitute for matrix A and I and capital A as it is. As we know that we have to convert our left hand side matrix into the unit matrix. Therefore, the second row first element should get 0. By looking at this number, we apply the respective row operations. Let me change the second row. R2 changes to R2 minus 2 times R1. Let me multiply the second row first element to the corresponding element of the first row and the first row element to the corresponding element of the second row. Therefore, R2 changes to R2 minus 2 times R1. By applying this, we will get the elements 0 in the second row. Since we are not changing the first row remains the same 1, 3. We are applying the change in second row. Therefore, R2 changes to, the R2 first element is 2 minus 2 times the corresponding elements of the first row, that is 1. Therefore, 2 minus 2, that gives 0. Therefore, the first element of the second row is 0. Similarly, the same operation we can perform to the second element of the second row. Therefore, R2 element is 7 minus 2 times the corresponding elements of the first row is 3. Therefore, 7 minus 6, that gives 1. Therefore, element in the second row second element is 1. We got a 0 in the second row first element. Similarly, we apply the same operation to the right hand side. We get, since we are not changing the first row remains the same 1, 0. Now let me apply. R2 changes to, R2 is 0 minus 2 times the corresponding elements of the first row is 1. Therefore, 0 minus 2 is equal to minus 2. And therefore, to the right hand side, the first element is minus 2. Similarly, R2 changes to, again, the second element we have to change is R2 element is 1 minus, according to this formula, 2 times R1. R1 is 0. Therefore, 1 minus 0, that gives again 1. Therefore, the second element of the second row is 1 to the right hand side into matrix A. Now, the next, our intention is to get 0 in the first row second element. Here we should get a 0. For that, we should have to change our first row. The second row remains the same, that is 0, 1. To the right hand side, second row remains the same, that is minus 2, 1. Now let me apply the sequence of row operations. R1 changes to, R1 first element is 1. 1 minus 3 times the corresponding elements of R2, that is 0. Therefore, 1 minus 0, that gives 1. For the first row, first element is 1. Similarly, we apply the same row operation to the second element of that matrix. Therefore, it is R1 is 3 minus 3 times the corresponding elements of R2 is 1. Therefore, 3 minus 3 is equal to 0. Therefore, we get 0 in the first row, second element. Let me apply the sequence of same operation to the right hand side. As I told you, we are not changing the second row remains the same. We are going to change the first row. Therefore, R1 first element is 1 minus 3 times corresponding elements of the second row is minus 2. Therefore, 1 plus 6, that gives 7. Therefore, the first row first element is 7. Similarly, the second element of the first row is 0. Minus 3 times the corresponding elements of the second row is 1. Therefore, 0 minus 3, that gives minus 3 in the first row, second element, into matrix A as it is. Now, dear students, you can find to the left hand side, we have the matrix like 1, 0, 0, 1, and that matrix is called as identity matrix denoted by I. And the remaining matrix to the right hand side is called as a matrix B into A. Therefore, we have proved that I is equal to BA. Therefore, the matrix B is called the inverse of A. Therefore, the inverse elements in this matrix are 7, minus 3, minus 2, 1. Let me take the one more example. Let capital A is equal to 2, 1, 1, 1. In order to use the elementary row operations, we can write A is equal to I into A. Let me replace matrix A as 2, 1, 1, 1 is equal to the identity matrix 1, 0, 0, 1 into A. As we know, we want the unit matrix to the left hand side. Therefore, we interchange the first and second row. R1 is replaced by R2 and R2 is replaced by R1. Therefore, interchanging the first two rows. The first row is replaced by the second row. First row is replaced by the second row. And second row is replaced by the first row. Therefore, we get here 1, 1 in the first row. And first row is replaced in the second row 2, 1 is equal to the right hand side also apply the same operation. First row becomes 0, 1 and second row becomes 1, 0 into matrix A. Now let me try to get a 0 in the second row first element. Here we want a 0. Therefore R2 changes to R2 minus 2 times R1. 1 times R2 minus 2 times R1. Since both the elements are same in sign, as I told you in the earlier slide, we should go for subtraction. And both are different in sign, we should go for addition. Now R2, since we are changing the second row, the first row remains the same. Therefore change in R2 is R2 first element is 2 minus 2 times the corresponding elements in the first row is 1. Therefore 2 minus 2 is equal to 0. Similarly, we apply the same operation to the second element. It is 1 times, that is 1 minus 2 times the corresponding elements of the first row. Therefore 1 minus 2 is equal to minus 1. Therefore here we have minus 1. The same operation we can perform to the right hand side. Therefore the first row remains the same 0, 1. We perform this operation to the right hand side. R2 is nothing but 1 minus 2 times the corresponding elements of the right hand side matrix is 0. If 1 minus 0 is equal to 1, that gives in the second row first element. Similarly, the same operation we can perform to the second element. R2 is 0 minus 2 times R1 is 1. Therefore 0 minus 2 is equal to minus 2. Therefore the second row second element is minus 2 and then A remains the same. Now let me try the 0 in the first row second element. Here you should get a 0. Now we want to write the first row. We should rewrite the first row. Therefore R1 changes to R1 plus R2. Since both are same in number and they are different in sign, that's why we go for addition of these two rows. Since we are not changing the second column, the second row elements are same on both the sides, we are going to change the first row. Therefore apply the row operation. R1 changes to R1 plus R2. Therefore the first row is 1 plus its corresponding element is 0. Their addition gives 1. Therefore here the element is 1. Similarly, the first row second element is 1 plus the corresponding elements in the second row is minus 1. That gives 0. Therefore here it is 0. The same operation we can perform to the right hand side. The first row first element is 0 plus corresponding elements in the second row is 1. Therefore 0 plus 1 is 1. Therefore in the next matrix we get a 1 in the first row. Similarly, second element of the first row is 1 plus corresponding elements of the next is minus 2. Therefore 1 minus 2 is equal to minus 1 in the first row into matrix A as it is. As we know that to get the inverse of a square matrix, our left hand side matrix must be in the form of a unit matrix. We have the first two elements 1, 0, but in the second row we have the element 0 minus 1. To get 1 in the second row, we should multiply minus 1 to the second row only. That we can see in the next slide. Now here we have the first row elements 1, 0. The second row elements in the previous slide we have 0, minus 1. We are multiplying minus 1 to the second row. Therefore, we get 1, 0 in the first row as it is. Minus 1 into 0, that gives 0. Minus 1 into minus 1, it gives 1. Is equal to the first row of the right hand side remains the same. And in the previous slide to the right hand side we have 1, 2. 1 minus 2. We are multiplying by minus 1 to the second row also. Therefore, minus 1 into 1, that gives minus 1. And minus 1 into minus 2, it gives 2 into matrix A. If you look at the above equation, to the left hand side we have the identity matrix I is equal to, if the once we get the unit matrix to the left hand side, then the right hand side this matrix will be called as a matrix B into A. Therefore, we have come to the conclusion that I is equal to BA. Therefore, B is nothing but A inverse, and the inverse of a matrix A elements are 1, minus 1, minus 1, 2 is the inverse of a square matrix. With this, we conclude the today's class. If you have any queries, please contact the given below number. Thank you. Stay home, stay safe.